Next topic, definition of cross correlation. Cross correlation measures the similarity between two random processes. The cross correlation between random process xt and yt is a measure of the correlation between them at two different time points. Cross correlation of two random processes xt and yt is defined as rxy t1, t2, which is equal to expected value of x of t1, y of t2. Some examples: a comparison of yield of crops and rainfall, age and weight, price of gold stocks and steel stocks, two independent signals. That is, normally correlation is the comparison of the similarity between two variables normally, right? Whatever it is, random variable, whatever it is. When we are comparing two variables, we are using correlation. Similarly, autocorrelation is the comparison or similarity of a same variable, that is random variable or random process, in the different time intervals. Cross correlation between random process is the same as a measure like correlation and autocorrelation. The correlation between the two random process at two different time points, that is also a comparison or similarity. So, yield of crops and rainfall. Based on rainfall, yield will increase, right? If it is correct rainfall or requested rainfall, then the yield of the crops will be more. If there is no rainfall, the yield will be very less, we know. So we are comparing yield of crops and the amount of rainfall. Then age and weight. When age increases, weight also increase, right? Price of gold stock and steel stock, definitely there is a difference. Then two independent signals. You can take any sound, music. There are different types of music signals are there. They are all independent, right? We can compare those signals also. That comparison also cross correlation. Next, joint wide sense stationary. Two random processes x of t and y of t are set to jointly wide sense stationary if x of t is a wide sense stationary, that is x of t, expected value of x of t, that is mean, is a constant. R of x of tau is a function of tau. That is x of t is a WSS. Similarly, y of t is also a WSS. That means expected value of y of t is a constant and RYY of tau is a function of tau. And third one, the cross correlation RXY T1 T2 is a function of time difference. That is RXY tau is a function of tau. We know RXY t comma t plus tau, which is equal to expected value of x of t, y of t plus tau, that is equal to r xy tau. some results. These are all the basic results. Arithmetic mean of a and b, we know a plus b by 2. Geometric mean of ab is square root of ab. We know geometric mean is always less than or equal to arithmetic mean. Next, we are going to see cross covariance. Cross covariance of x of t and y of t is defined by c x y t1 t2, which is equal to expected value of x of t1 minus mu of x t1 into y of t2 minus mu y of t2. Mu x is the mean with respect to x of t. Mu y is the mean with respect to y of t. Now see x of t1 t2, which is equal to expected value of x of t1 y of t1 minus expected value of x of t1 into expected value of y of t2. That is equal to expected value of x of t1 into y of t1 minus mu x into mu y. So see x y t1 t2 cross covariance, which is equal to r x y t1 t2 minus mu x into mu y. It is same thing. Instead of mu x, we can replace the expected value of x of t1, mu y, expected value of y of t2. Cross correlation coefficients. We know Carl Pearson's correlation coefficient in correlation, same formula we are using here. Cross correlation coefficient is defined by gamma rxy rho xy t1 t2, which is equal to covariance of xy divided by root of covariance of x to covariance of y, right? Next, we are going to see the properties of the cross correlation. Property number 1. If x of t and y of t are two WSS process, White's and stationary process, then rxy minus tau, which is equal to ryx tau. We know that rxy tau, which is equal to expected value of x of t into y of t plus tau. Replace tau by minus tau, so we will get rxy minus tau, which is equal to expected value of x of t, y of t minus tau, which is equal to expected value of x of t minus tau plus tau, y of t minus tau. That is equal to expected value of y of t minus tau into x of t minus tau plus tau, right? X of t we can return as x of t minus tau plus tau, adding 1 tau and subtracting 1 tau because of our convenience. So take t minus tau as t1, so you will get the expected value of y of t1 into x of t1 plus tau, like the same formula. So we can write it as ryx tau. Next, property number 2. Prove that modulus rxy tau less than or equal to square root of rxx0 into ryy0. We know that cos is squares inequality. Expected value of x of y whole square less than or equal to expected value of x square into expected value of y square. Now rxy tau modulus value square, which is equal to, we know expected value of x of t1 into y of t2 the whole square modulus. By using cos squares inequality, which is less than or equal to expected value of x square t1 into expected value of y square t2. This is nothing but rxx of 0 into ryy of 0. We know the property of autocorrelation. In the autocorrelation, we saw that expected value of x square is equal to r of 0. So rxy tau whole square, it is within the modulus less than or equal to rxx of 0, ryy of 0. Next property, prove that rxy tau modulus rxy tau is less than or equal to rxx of 0 plus ryy of 0 by 2. So we know the property number 2, from the 2, Rxx of tau the square modulus is less than or equal to Rxx of 0 into Ryy of 0. Taking square roots on both sides, Rxy tau is less than or equal to square root of Rxx0 Ryy0, that is equation number 1. We know that geometrical mean is less than or equal to arithmetic mean. So Rxy of tau, which is less than or equal to Rxx of 0 plus Ryy of 0 by 2, because this is geometrical mean Rxy from equation 1 and 2. That is square root of Rxy0 or Yy0 is less than or equal to, here using geometrical mean is less than or equal to arithmetical mean Rxx of 0 plus Ryy of 0 by 2, that is equation number 2. So 1 and 2 we will get less than or equal to 2. Next definition, orthogonal. Two random processes x of t and y of t are said to be orthogonal if the cross correlation Rxy, which is equal to 0 for every t1 and t2. Uncorrelated. If two random processes x of t and y of t are said to be uncorrelated if the covariance, cross covariance Cxy, which is equal to 0 for every t1 and t2. That's all. Thanks. We'll see you in the next video.